We're live. We'll see. Okay, today we're doing arc length. Oh, it works. It just is a restart kind of day. All right, suppose we have some function, f of x, like so. It wiggles all over the place. This is our f of x. And instead of finding area under the curve, or a volume of revolution, or a volume by known cross-section, this time I want you to tell me how long it is. But it's not straight. I want to know how long this thing is from A to B. Suppose you have some equation describing the path of a subspace particle or some sort, and you want to measure how long it is, what its path is, how long the path is. This would be something like that. Something weird, not just straight line things. Well, we're going to go back to the things we know in calculus. What do we do in calculus? What do we do in the very beginning? Did we take a snapshot of something and zoom in, right? So if I take this right here, this square right here, and I take a picture of it, and I go off to the side and I zoom in on that, actually I'm going to zoom out. But suppose I go off this and I'm going to zoom in. It's a microscopic view of that. Like I'm really, 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 really close to it. I'm not even doing that much of a square. Hang on, let me erase that. A really tiny square. Let's do a really tiny. So I'm taking a little tiny square like that and I'm zooming in. So I have this point right there, right? And barely perceivable is the curve. Barely perceivable. But can I draw a tangent line through there? And is it really close to my function? And that tangent line, instead of a tangent line, I'm just going to do a line segment, and I'm going to produce a piece of line where I can describe this length L in terms of delta x and delta y. Does it look familiar? You've done this before, right? We're finding the length of something. You've done it with vectors. You've done it with just Pythagorean theorem back when you were in middle school. Do we all agree that that length right there, that length, and we're going to call that for a little subsection I, because can I do an infinite number of those little line segments, connect it all up, and essentially if my number of line segments goes to infinity, will I get the exact length? Does that sound like a limit process? Right? Instead of adding up areas, I'm adding up these little lengths. And each one of those little lengths is equal to the square root of the delta x for that little segment square. Okay, hang on. I'm writing so small. Hang on. Let me make it bigger. The delta x for that little line segment squared plus the delta y for that little line segment squared. And if I add up an infinite number of those, will I have the exact arc length? That's distance formula, which is Pythagorean theorem solved for the hypotenuse, right? That's all we're doing. Oh, but wait, there's a little fancy stuff we got to do, because we got to have a dx in there. Because is this a limit process? And if we did the limit process, would it turn out to be an integral? So how does that relate to our integral? Everybody got it written down? And why am I showing you this? One, I want you to understand the theory. Two, I want you to understand where the formula comes from, because this is one-dimensional, right? This is one-dimensional motion. I'm finding the length whenever things with respect to some function with respect to a length with respect to time, some distance with respect to time. Eventually, are we going to do two-dimensional? So I need you to understand where the one-dimensional equation comes from, because it's different than the two-dimensional, and you're going to have to understand the difference and make sure you don't use the wrong equation at the wrong time. All right, so I have that L sub I equals the square root of, and oh, hang on, I need to make room for myself. Hang on, I'm going to need some room. Leave a little space. And I have that delta, it's a delta, I'm saying it but not writing it, delta x sub I squared plus delta y sub I squared. And what I'm going to do is, I need to get a delta x out there, right? Outside. Well, what's the square root of delta x squared? It's delta x, right? So what I'm going to do is, I'm going to factor out a delta x, which means that I am dividing both of them by the delta x squared. Is that the same as having a 1? Does everyone understand what I did? It's I. It's for that one line segment I, right? What I did was, if I factor out a delta x squared, take the square root of it, if I put this back in, it's going to be a delta x squared over delta x squared, that's 1. All I did was multiply both terms by 1 in the form of delta x squared over delta x squared for that segment I. If we take this and we add up an infinite number of those, is that the arc length? Oh, hang on, I want a different color.